Live? I
We're
think it's
live.
live.
All right.
Howdy, everybody. Welcome to GCP Online Meetup, episode number 56.
56. There
Celebrating. Ooh, that hurt. Let me take this off.
it is.
I'm Mark Mirchandani, customer engineer here at Google.
And I'm Anthony Bushong, also customer engineer here at Google.
So, what are we talking about today, Anthony?
Well, I think that after 56 sessions,
Yeah,
a
yeah.
good portion of them have covered Kubernetes uh, from a Kubernetes perspective. And that sounds a little weird, but let me explain.
Yeah.
It's we know that Kubernetes is open source, driven by a large community. But I think that we haven't spent too much time talking about specifically Kubernetes on Google Cloud Platform, right? So today I was hoping that we could take a brief tour of Google Kubernetes Engine, which is Google Cloud Platform's managed Kubernetes offering, and show just some of the benefits that you stand to gain running Kubernetes on our platform. And so I'll be reviewing that. And the reason I'm also calling it part one and talk about it a little more later is
Yeah.
like there's a lot to cover.
Yeah, absolutely. I mean, like, we only have a certain amount of time here. So,
Exactly. So we will treat this to some degree as an introduction to GKE as well,
okay.
is
Perfect.
what we call it, GKE.
I'm already looking forward to part two.
Awesome.
Let's get into part
Let's
one.
get through
Then.
part one first. So this is not a session to talk about the architecture of Kubernetes from an introductory level. We'll assume that there's some familiarity with it. I put this here just because I think it's funny. Kubernetes has certainly garnered the reputation of being the latest and greatest, and for good reason. But this is just a little nod at kind of the hype around it. It's the answer to everything. It's 42.
Yeah, right. But we've seen a couple of different episodes specifically about Kubernetes.
Certainly.
So I think that we'll talk a little bit about it here. But if you go into the GCP Live channel, you can check out a lot of other videos that
Sure.
kind of cover the more Kubernetes aspect
Yeah.
of it.
And Kubernetes adjacent technologies like Istio.
Oh, absolutely.
Boom. All right, cool. So I'm just going to show a very brief introduction to level set our understanding of Kubernetes. And so I have an existing Kubernetes cluster. I'm just going to run this from the Kubernetes command line tool, kubectl or kubectl or kubectl. And so what we're looking at is a very kind of 10,000 foot view of what Kubernetes brings you. So you'll see here that in my cluster, I have 3 virtual machines, and we'll talk about a little bit about these virtual machines later. But the point is that Kubernetes gives us a way to abstract away that infrastructure, think about our containerized applications, and get them running, right? So you'll see here that those containers are represented as pods. I have 3 Nginx pods running in that cluster. These are provided resiliency by a Kubernetes object called replica set, which guarantees that I'll have 3 at any given time. We have a deployment, which is above a replica set, gives us some update strategies. And then, so that controls how we run those containers. Kubernetes gives all of that out of the box, which is nice. And then on the other side of the coin, we have how we expose these services to our end users, right? So you'll see here that I actually have a service called Nginx with an external IP address. And then each of those containers have their own internal IP address associated with that service, right? So I can kick over to this. Actually, I think I already have it open. And so if I hit that actual endpoint, we'll see here that I have those Nginx. I'm being served by one of those Nginx containers.
So this is a relatively simple example of being able to host a web server in this case, of course, on Kubernetes.
Oh, yeah, absolutely.
Scaling it to a couple of different pods and clusters, and just being able to say, like, I have this more resilient hosting infrastructure.
Right. Right. And this is, again, just some of the very basic building blocks that Kubernetes gives you. Obviously, there's a lot more. And obviously, Kubernetes supports a lot more dynamic workloads than just an Nginx web server.
Sure.
But for the sake of simplicity, that is what I have running, level set, done.
Sure.
But when we talk about Kubernetes, outside of the basics, there's so many different areas to chase down. And so it kind of feels like this when I'm trying to navigate the Kubernetes ecosystem and all the different toolings, all the different ways and patterns that you can implement role-based access control, or the different ways that you can schedule specific workloads on specific machines, right? There's a ton of stuff. And I think that a lot of the time we talk about the magic of that Kubernetes has to offer, right? Getting this in a very declarative way, a simple way. And that's the benefit that Kubernetes brings users. But from my perspective, when I really try to boil down how, not how entire organizations should think about Kubernetes, it's a tale of 2 parts, right? So there's actually using Kubernetes, and that's what this brief demo showed, right? We're able to see, kind of all of these different components, these Kubernetes objects working together to get my container up and running and exposed to the public, right? And so I think Joe Bita, he's one of the founders of Kubernetes, described it a little bit like jazz. A lot of different players responding to one another, but ultimately it comes out really smooth, and it's this is the reason why Kubernetes has gained a lot of traction in the industry. But on the other side of the coin, I think that the second tail that we really have to think about is how do we run Kubernetes, right? And so what do I mean by how do we run Kubernetes? Let's start with day one operations, right? We actually have to bootstrap the cluster. We have to think about getting all the appropriate control plane components installed and running. And I'll talk about that in a little bit. We have to think about spinning up our virtual machines, getting kubelets deployed onto each of those agents or onto those virtual machines. We have to think about how we're enabling secure communication. We have to implement networking. We have to think about how whether that's using a cloud provider's routing mechanisms, or are we implementing a network overlay, right? These are some of the things that from day one we have to consider in order to get a functioning Kubernetes cluster. And then day two, we have to, we get our cluster up and running. We have to manage a control plane. This is responsible for scheduling and deploying your workloads. We have to make sure that this is secured, that this is able to scale to handle, let's say, more writes to its backing store. We need to ensure that we're upgrading to the latest versions, as sometimes the Kubernetes binaries will have patches for security, or you just want to use new Kubernetes features in your workloads. You have to maintain that control plane in order to do that. And then there's the node lifecycle, right? Control plane's responsible for scheduling our workloads. What about the actual hosts running these containers themselves? Are they healthy? Are they experiencing some type of disk pressure, or are they in an unreachable state? These are things we have to think about, and these are things that we ultimately have to set alerting and our operations or SRE or whatever you call that team has to be in practice of managing this node lifecycle as well. And then finally, there's implementing value add integrations. So this could be like, I want to now run multiple Kubernetes clusters, and how do I route users to the nearest Kubernetes cluster closest to them, right? Am I achieving this at DNS? And I have to configure that. And that's just one example, but there's a ton of different things that you may want to enhance your cluster with to give you more visibility or something like that.
And I think that it's a great point, and Istio is another great example of a value add, right? Is
Sure.
You kind of deploy Kubernetes and you start to kind of move workloads in there. You really got to look at what things you're doing inside of that and how you're going to make sure that can move forward, kind of considering all of these. So when someone's like, oh, I have all these containers and I want to put them out there and I want to start running on them, there's a lot more to it than just saying Kubernetes will solve all my problems. It will. And I think in a lot of ways is what, you kind of mentioned earlier, right? Mm-hmm. It is really the answer to everything, but it's not just a click. It's not just a click to deploy kind of thing.
Yeah. Yes. In its open source implementation. But
exactly.
That is where Google Kubernetes Engine comes into play. So let's talk about what running Kubernetes actually looks like with GKE. And again, part one, because this is very intro level GKE stuff, and there's a lot more advanced topics that I'm hoping we can have further sessions on. So the two main areas that I'm going to be talking about today with Google Kubernetes Engine is the cluster lifecycle. So again, some of the things that I was referring to in those previous slides. And then we'll talk about integrations with Google Cloud Platform, right? What are some of the other ways that GKE hooks into Google Cloud Platform native products and solutions in order to make some of the different use cases on Kubernetes possible, or enhance the experience of the users. So let's jump into GKE. So you mentioned that there's no easy click to deploy button. I will note that in GKE there actually is, in order to get Kubernetes up and running. But for the sake of this slide, I actually represented it as a command line.
Sure.
And so, G-Cloud Container Clusters Create uses the CLI for Google Cloud to actually create a Kubernetes cluster for you. And so what that'll actually give you when you execute that command is a very standard Kubernetes control plane that's running open source Kubernetes. So it's nothing vendor specific to Google only. And so, again, we want to maintain the openness and the promise that, what you run on Kubernetes can run anywhere, including GKE. So this is a Kubernetes control plane. The thing that's different about it is that it's entirely managed by Google's SRE team, and it's in a Google managed project. And so what's cool about that is that when we create this cluster, that control plane is configured to have secure communication with the virtual machines that are running our actual hosts in our cluster, right? So we have TLS configured between the Kubernetes control plane and the virtual machines, so that there's secure communication. If we're using Kubernetes secrets or something like that, that's something that we should really think about when running our cluster. With GKE, it happens automatically.
Yeah, and I think that it sounds like obviously having Kubernetes running on GKE makes things a lot easier. And you mentioned kind of the openness where it supports the same stuff that's running, whether you have it running local hardware, whether you have it running on another cloud provider, whatever it is, you can kind of easily take that configuration, move it around without making any changes.
Oh yeah, absolutely. And that's not to say, so this is a very simple diagram, but what's pretty cool is that we actually will deploy other certain things that represent some level of opinion in this Kubernetes cluster. So kubedns, for instance, we deploy it with an autoscaler. We implement, if you want to enable logging, for instance, in your Kubernetes cluster, we'll deploy a daemon set to actually write logs to Stackdriver as a backend. And so there's a lot of different things that you can get for free in this kind of click to deploy scenario. But really, the base of it is that we are managing this control plane for you, and so that manifests itself in some pretty key ways, right? So this control plane, for a quick review, is that it's comprised of an API server. So this is what kubectl is a wrapper around. We're just interacting with this API server to persist new objects into our Kubernetes cluster, and then all these different tools in Kubernetes are interacting with the API server in order to do their function, whether it's a kubelet, whether it's a scheduler and whatnot. So all of these different pieces are deployed and managed by Google for you, and it's backed by an SLA. So you're able to have, and the SLA will depend, and I'll get to that in a second, but it's pretty cool knowing that one of the more challenging pieces of managing Kubernetes infrastructure is actually handled for you automatically.
So you said that this was managed by Google. What are some of the kind of things that might relieve off of your ops team?
Sure. So let's say we start with a Kubernetes cluster that maybe has a few nodes, but as we scale that up to an order of hundreds of nodes, right, we're taxing our Kubernetes control plane more. And so something that you have to think about when you're running your own Kubernetes cluster is, okay, well, how am I actually representing this control plane? I think the box here is a little misleading, like, oh, this is just one virtual machine. It can be, but I've seen other customers implement etcd clusters themselves, right? And etcd is a non-trivial thing to manage and scale and implement, but that's something you'll have to do when scaling out your actual infrastructure, right? Because maybe we're writing more to or persisting more Kubernetes objects, or just the actual scale of the cluster will mandate and warrant that actual scaling event. That's something that we have to think about. We have to have an operations team, and it goes back to that running Kubernetes and not using it story, right? So that's really where our Google SRE team will actually scale your Kubernetes control plane for you. Sweet. So upgrades also are automatic. I think this is key because Kubernetes is developed at a very fast-paced velocity. So if you want to take advantage of new features, you'll want to obviously easily upgrade GKE or your Kubernetes control plane, because the last thing you'd want to see is people wanting to take advantage of some of these new Kubernetes features in a new version, and now you have to put that aside or table it because it's quite an action to actually upgrade your master, right? So this is something where upgrades are automatic, and you can choose to opt into upgrade. So there is an also click to upgrade button, and Kubernetes tracks the open source minor releases pretty closely. So I think that's pretty cool. And I think I already touched on the scaling point, but again, really, this is one less thing that we have to feel like Indiana Jones about trying to manage, that actual control plane. Google does it for you in GKE. So another thing that you might want to think about is when rolling your own Kubernetes cluster is, how do I achieve high availability, right? High availability is important because maybe I want to do an upgrade for my Kubernetes control plane, but if you only have a single master, obviously there's going to be some downtime. Well, in GKE, we have something called regional clusters. And what's cool about that is that we'll have 3 replicas of the Kubernetes control plane. And that actually allows you to do rolling upgrades and things like that with zero downtime, right? And now we're able to also have high availability. God forbid anything happen to a given zone, we know that we have our replicas represented in 2 different zones, right? So, or our control plane represented in 2 different zones. So these are things at a very control plane level we're able to provide for you. And we provide secure communication between our different Kubernetes masters. So things like secrets or other sensitive data is still secure.
And when we come to, kind of talking to people about what their different workloads are and what they're trying to implement, we always recommend high availability. I think it's general industry standard to kind of protect yourself in case of any outages. And so this is a great example of something that can be a lot of work. If you're going to deploy this in your own infrastructure, you're going to have to put a lot of effort into making sure that you're going to have to make sure that you kind of spend a lot more time there in taking care of where your traffic's going to be coming from, how it might get redirected when something goes down, how to basically make sure that your entire workload is stable regardless of any outages. And so by kind of relying on someone else to do that work for you, you really don't have to worry about it.
Exactly.
Perfect.
So this is where, I think that over time, we'll see this controlled or managed control plane be somewhat of table stakes across Kubernetes. Right? I think there's still a lot more of focus, not just in GKE, but in the community, to really focus on that using Kubernetes. How do we build things atop Kubernetes and less on this? So I think that, while GKE provides a lot of wonderful things at management of the control plane, I think really some of the things that Kubernetes Engine does special lies at the lifecycle of the actual nodes themselves. And so this is kind of an auto everything type of mentality when managing your actual virtual machines running your containers. So one feature that you can enable in the GKE cluster is called node auto repair. So this is something where, underneath a GKE node pool is a concept of a managed instance group. So if I delete a node, one will be spun back up. That's great. But what about if my node is there, but it's failing specific health checks? Let's say it's in an unreachable or a not ready status. Or let's say that it's experiencing some level of disk pressure. This is something that GKE will actually notice for you and take actions to create a healthy node in that unhealthy node's place. So node auto repair is something that, typically this would be a scenario where someone's getting paged. Maybe I have some alert based on some of these health checks, and now I'm having to take action. In GKE's case, this will be done automatically for you when you opt into it. So you can retain that control if you don't want to take advantage of this, but knowing it's there is something that I've seen a lot of customers take advantage of.
Yeah, I mean, it's another one of those kind of features that, we think is really helpful. It's great because if you're coming into Kubernetes and you're like, hey, I want to do this, I don't want to manage a lot of this stuff. GKE is going to solve those kind of problems. But if you don't want to do that, you kind of just don't implement it, right? Just have it, and then you can either implement your own structure for it or whatever your kind of specific needs are. You don't have to use this. And a lot of the features of GKE kind of are structured that way. So they're there to help you. They're there to make your life easier. They're there to make sure that you don't have to worry about nearly as much. But if you want to go in and assume control of those things, you still have that as well.
Yeah. And there's actually a good case study of a customer that I helped migrate into GKE that's public on our website on Smite. And they actually talk about a lot about how when they opted into GKE and migrated into it, taking advantage of these features really quieted their pagers down. So if anyone is curious, go check that out on the public website.
We'll have to put that in the description.
Sure. Yeah, I'll throw that in there. A couple other things, and these are a little more easier to understand. So there's auto upgrade at your node level too. So I can actually spin up new versions of, let's say, or I can spin up new virtual machines with the latest version of Kubernetes, as well as instead of having to patch a host that I actually care about, I'm trying to take care of, like I can now just replace them with the latest image of container optimized OS. And I think GKE also supports Ubuntu at the OS layer as well. I'm not sure if that supports auto upgrade, but the idea is there as far as, if we want to get to an immutable future, right, but we're still treating our hosts in our Kubernetes cluster to some degree with care, right, it sort of takes away that benefit. And so being able to implement security patches by just upgrading your node pool, it's a pretty cool thing. And then auto scaling. So cluster auto scaling, that's a Kubernetes wide feature. This is something that is just a checkbox or a flag in the command line tool to be able to enable this at max and min And then basically your Kubernetes cluster will be able to scale, as pods are failing to be scheduled because all of the allocatable resources are taken up in a cluster. You'll see new nodes that are added. So you can very easily implement this where as you're trying to figure out how to implement this when rolling your own Kubernetes cluster may be a little more difficult.
Yeah, I think it's nice to see that just on this slide alone, all three of those kind of start with the word auto, and I think that's a great kind of explanation of like hey, these things are all meant to kind of once you turn them on or once you kind of configure them to work for the way that you want them to, you can take a step back, right? The whole point of this is to kind of make your life as easy as possible in order to focus on what are actually like the important things to you.
It's not too cheesy that I led with auto.
No, I love it. I love it. I think it's perfect.
Sweet. So that's just a little bit on the cluster lifecycle, right? I think there's a lot more, and in a further session, I'd like to have either myself or someone else cover some of the deeper dive things. But I want to spend some time on the integrations with Google Cloud Platform, right? Because to some degree, right, there's the promise of Kubernetes that you'll have parity everywhere, but the part of that is dependent on the infrastructure that you're actually running on, right? So infrastructure in Google Cloud Platform may behave differently from a different cloud provider. Load balancers may be represented differently than other cloud providers. Same thing with storage, things like that. So I want to talk a little bit about how GKE integrates with Google Cloud Platform components that make it a really special place to run Kubernetes.
And I think you have a question that's very related to that. It's very specifically, whether GKE offers any dashboard to kind of monitor the virtual machines or the nodes that you're actually looking at.
Sure, yeah. So it does. You can actually view your infrastructure in Stackdriver monitoring.
Okay.
So there are dashboards there. There's also some level of, actually you can jump to that. So here's like a Kubernetes cluster, or I'll get to the Kubernetes Engine UI in a second.
Sure.
But basically, I can look into Compute Engine and actually see all of the different virtual machines that are comprising. I have 5 different Kubernetes clusters up and running, but I can actually go into here and see some very basic level of metrics on my virtual machines, so like CPU utilization and things like that, some network statistics as well. But if you want to make some custom charts, you can absolutely do that in Stackdriver as well.
Mm-hmm.
So that's one thing that's great is that Google Kubernetes Engine integrates with an opinionated way of doing monitoring and logging. However, there are other ways that you can also run other monitoring tools. Certainly, there's a bevy of examples of that we can share with. But if you're looking to do something without kind of in a no-op way, this is provided for you for free.
And so much in theme with this entire conversation, there are tool sets inside of GCP that let you just monitor. You can hook it up to Stackdriver. You can create dashboards. You can take the data. You can do whatever you want with it, or you can get access directly into those nodes and pipe it off to whatever your kind of custom configuration might be.
Sure.
So
absolutely
an easy way to kind of look at the control plane, look at all the nodes, and kind of just monitor them all without having to do any additional work.
Awesome. This leads me right into this section. Thanks, Mark.
Yeah,
did you plant that?
I did. That's not a plant, but it was very good timing.
So one of the things I actually want to show that I think is awesome, and I have a lot of customers taking advantage of this, is preemptible VMs. So preemptible VMs, I think one of the cool things that I love about GKE is that it really follows true with what I see in the community as far as Kubernetes is really made to be for dynamic workloads. In a microservice architecture, we could have something as simple as a web server, but we could have something doing a very complex, some type of either machine learning or some type of event processing. I think an example that I saw recently was Spark creating a way to run on Kubernetes. And so the fact that we can run all of these different types of workloads, it should yield to the fact that we need different types of hardware to be able to accommodate those different types of patterns. Some may be very CPU intensive, some may need hardware accelerators. One of the things, so the point that I'm trying to make is that in Google Kubernetes Engine, we can have in a single cluster, multiple configurations of different machine types, right? And so each of those would be represented as a node pool. So, you see in this Kubernetes engine diagram that I actually have 3 node pools in this cluster.
Mm-hmm.
We have maybe the default pool. This could be, some very lightweight resources.
Sure.
Maybe node pool N has GPUs, which actually you can create in Kubernetes Engine. And then lastly, we have preemptible node pools. And so I want to focus on that So preemptible node pools is a type of compute engine instance that could be preempted. It at longest lives about 24 hours and can be preempted at any time in that. And what's great is that Kubernetes engine seems to be a match as far as, or not Kubernetes engine, just Kubernetes in general for preemptible VMs. Because if, let's say, a node preempts, if we're using some of these higher level objects like replica set, things like that, those pods should be rescheduled elsewhere in the cluster. And so now we're getting, if those nodes are preempted, we can count on our workloads automatically being scheduled somewhere else in the cluster, and we get to take advantage of the across the board discount for running these preemptible VMs. So I think it's like something like 70 or 80%. Don't quote me on that, but it is a large discount that is provided automatically for running these preemptible.
Yeah, and if it's a perfect fit, if you kind of have that workload that can be transferred over and you don't mind, I don't need these machines to be very long lived, you can just kind of say, well, let me save my money, right? Because preemptible VMs are mainly focused on, I have these workloads that can be moved around, very flexible. Sure. I don't want to pay for these things to be up the entire time.
Yeah.
So being able to run your kind of your configuration in Kubernetes and swip over to different workloads is perfect, right?
Yeah.
Or to different nodes, I should say, actually.
Yep. And one of the things I do want to note is that obviously there's no silver bullet. One of the things you may want to think about when running with a preemptible node pool is to introduce some jitter as far as VM creation so that they don't all preempt at the same time. There's some tools to do that that are open source out there, but ultimately, the trade-off there is to be able to take advantage of these cost savings. It's pretty cool.
Sure. And some of these, you had mentioned earlier, you can have the different pools that are different types of machines. And with Google Cloud Platform's ability to kind of customize your machine types by choosing, your exact amount of CPU and RAM, you can really kind of configure your individual workloads to be very, very specific to what resources you need on them.
Oh, yeah.
And then kind of have them all mastered or controlled from one master plan.
Exactly.
Perfect.
And so what I'm going to do is just quickly look at this preemptible node because I have this as one of my nodes in this cluster. So you very appropriately called it preemptible pool. So here's the host name that we have. And one of the concepts that you'll be familiar with in Kubernetes is labels. And so this is basically a way to use key value pair to kind of do specific things. And there's a lot of different use cases for that, but I'll call out this specific one. So we see that we have some default labels on our actual node here. And the one that I want to point you to is we have one that's cloud.google.com/gke-node pool equals preemptible pool, right? And so what we can actually do is use this label we can use this label to actually direct the workloads that we want, either using node affinity or node selector, to actually be scheduled on those preemptible pools. Mm-hmm. And there's ways to actually, if nodes can't tolerate that preemption, mm-hmm. then we can actually use taints and tolerations to keep workloads away from these virtual machines. So it's not something where it's like, well, I'm starting to be concerned if I'm scheduling workloads. What if a workload that can't tolerate that failure gets put on that node?
Right. You don't have to worry about it.
There are ways that are built in to kind of get around that. So the next thing I want to talk about, and this will just be brief, is that we do integrate with logging and monitoring, and this is again a way to kind of just enable that with a click of a button. We also integrate with audit logging, so we actually are able to see in Kubernetes who is doing what actions they're taking in a given cluster. So it does give us auditing as far as if we're running this in production, we want to know who is creating a specific deployment or something like that. So all of this is integrated into the Google Cloud Platform console. Mm-hmm. I think it's really useful for teams that are running in production that do not have an opinionated way of implementing this, but they just know that they need to implement it. So.
Yeah, I mean, again, it kind of goes into that idea of, hey, we're getting started with this. Let's put that in as our baseline. But if you already have this big workload or this other kind of configuration that you're using, you can plug that in just as well.
Yep, exactly.
We do have another question kind of related to what we were talking about earlier. So, as you mentioned before, GKE will automatically create new nodes or pods based on health check. And I think that's something that you can configure, right? You have that power to kind of define health checks and what Kubernetes is supposed to do in the case of these, or even what the managed instance groups are supposed to do with those nodes. How is data redundancy managed? And I think we might probably need a little more clarification on exactly what you want to look for there.
I think I can take that. So one of the things that may be Kubernetes specific, if we need data to persist outside of a specific lifecycle of a machine
Right.
or a container or pod, I'm sorry, we can use something that's called a persistent volume. And so that's more of a Kubernetes specific topic, but it basically will give you the ability to have specific pods have claims for those volumes. And then, if a pod gets rescheduled or moved elsewhere, there's controllers that will actually ensure that that persistent volume will follow, let's say, that pod where it's being rescheduled. And basically, it will live outside the life cycle of the virtual machine and the pod itself.
Right. So you can kind of create more stateful kind of applications.
Yep.
Okay. If that, let us know if there's any kind of follow up there. If you have a more specific one, we can kind of dive into that.
And so, I do want to wrap up with a couple last pieces of integrations with GCP. This is my favorite one, and it's relatively new. There's a tutorial for it on the doc side if you want to dive into it, called the, I think they call it multi-cluster ingress, but it basically allows you to integrate multiple Kubernetes engines as a backend for our global HTTPS layer 7 load balancer. And what's awesome about that is that we now can have a single VIP because the load balancer is actually represented at our different points of presence. There's no sense of a fleet or something like that of VMs that are representing our load balancing or our ingress point into these clusters. What we're actually able to do is use the Anycast protocol to actually be able to route users to the nearest GKE cluster. And so what I actually want to show you is, I cheated. Okay, well, so this is my single VIP represented by this load balancer. And so we have a multi-cluster ingress tool that will actually allow you to configure what I have set up. But this is a simple site that is showing me what GCP zone I'm being served from. So obviously we're in beautiful San Francisco, so I'm being served from USOS 1A, which is in Oregon, closest GCP region to me. But I could end the demo here and be like, so
that's it, we're done. Yeah, that's good. Yeah, West,
but,
perfect.
I do want to show that I actually also have a virtual machine in Europe, West 1B. Actually forgetting what actual geography that's in. But nevertheless, I actually want to hit that same virtual IP address.
Right.
And I want to see what we get. So now what we actually see is that I've been served by a different Kubernetes cluster that's pulling metadata of what zone it's running in. We actually see that we're served from Europe West 1B. And so this is something that, again, typically you're having to implement the DNS layer or something like that. And this is something that we get just from our integration with Google Cloud Platform.
Right, by kind of building on the other tools that are available in Google Cloud Platform.
Absolutely.
You can just set up this globalization very quickly, very easily, and using the single front end, from the browser, we had it logged into West because we're here in the West, and then this machine, I assume that you're SSH into here is over in the Europe side.
Yep.
And then when you ping it from there, it just shows.
It routes you directly to the Kubernetes cluster I have running in Europe.
Yeah, makes it super easy.
Yeah, and one note there is I've tried to do this demo in different either conference space or events, and I didn't know where the internet was proxying.
Yeah, you never know when it gets there, right? So you have to be very careful.
Yeah, but the demo gods were with me today. And so the last thing I really want to show is just dive into the user interface, right?
Oh yeah, just like we were talking about before.
So if I go into Kubernetes Engine, what's really cool is if we think about open source Kubernetes, we have the concept of a dashboard that ships with Kubernetes cluster, and that's open source, scoped to a single cluster, and requires a lot of work to actually secure properly, right? And so instead of having to deal with that and think about, how do we introspect across multiple different clusters? Like, what if I'm using staging and QA environment in one cluster and production in another cluster? I'm slowly, it starts to get more difficult as far as how am I getting a kind of single pane of glass to look at all of this stuff. And so GKE's UI will actually let me look at all the different workloads I have running across these different clusters. It will let me look at the different services that I have running in my different clusters. So my different load balancers, my ingress objects. And so it's really cool in the sense that this is something that is, again, provided at a no-op. Because you're creating GKE clusters, we now can get some insight into all these different workloads. And we can actually drill down into those, edit the YAML, actually look at a lot of interesting metadata that your team will want to know in order to maintain and manage these workloads. So,
yeah, kind of just another way to help you manage what you have and not need to worry about what's kind of going on. Or if you already have your kind of visualization layer or you already have your UI built out, again, you just build that right into it and you can use that too.
Cool. So just want to wrap up here. This was a very, very introductory level. There's so much about GKE that I get excited about.
Absolutely.
There's still a lot on our roadmap. So certainly I want to timestamp this, that this is just an introductory, April 27th of 2018, but who knows what the rest of the year and next year will bring us. But really, we'll try and keep up to date on GCP Online Meetup,
of course,
to keep all of you apprised to that. But I want to wrap up by talking about how Kelsey Hightower really tweeted this. I had to override it so the font looks a little funny because it used to be called Container Engine.
No worries.
But he called it the cheat code for Kubernetes. He has a tutorial called Kubernetes the Hard Way. If you're interested, I think it's a great learning exercise to actually bootstrap a cluster from the ground up yourself. And his tutorial is kind of the de facto for that. But he calls it the cheat code for Kubernetes. And again, his tweet really focuses in that tale of two parts that I had. Focus on using Kubernetes, don't focus on managing it. So that's it. That's all I had. Thank you for all of you for joining. Beyond part one, there was some very exciting news announced yesterday on the GKE front of the Kubernetes Service Catalog. And so this is a way to actually natively interact with other GCP services. And maybe this would be for part two from GKE clusters. So that's being able to natively interact with GCS or object storage, or let's say, some of our database products like Bigtable, Spanner, MySQL. I encourage you to go check out the blog. And anything else, Mark? Or
no, I mean, I think that it's a kind of, like you said, it's a great kind of overview example of some of the things that GKE offers.
Absolutely.
So regardless of kind of what you're looking at, you don't want to manage all of this stuff. And being able to take all the additional functionality, all of the kind of Google managed services, and then the integration that we actually have with the rest of the GCP world kind of just makes your life a lot easier. Right? You're not losing anything. You're only gaining the ability to not focus on the things that you don't care about. And instead, you get to focus on exactly developing your application.
Yeah, exactly.
I'll see if there's any last questions here, but otherwise, we'll go ahead and wrap up. Yeah, absolutely. We will share. We'll update the description with as much stuff as we can.
Sure.
Links out to some of the different the tutorial you mentioned. Certainly Kelsey Hightower's Kubernetes the Hard Way. Right. I mean, it's such a great resource for kind of seeing from when you go from that ground up perspective of exactly how much stuff there is when you're implementing this and how much work there is that needs to be done. So it's a great example of, if you step through this, you learn a lot, but then you don't want to have to do it again.
Awesome. Well, thanks for having me, Mark.
Yeah, absolutely, man. Thank you so much for presenting, and thanks to everyone for coming out. We'll hopefully see you soon, right? Yeah. Maybe part two soon, right?
Absolutely.
All right. Thanks, everyone. Bye.